Hello everyone, welcome back to a new video, Pi Nation, and I am Pi Nation. We're back, brought some interesting videos for the whole class at syllabus. Yes, I'm going to complete the whole class 8 syllabus, and there is gonna be a playlist for class 8, then sub playlist for each chapter. So without wasting time, let's start our first chapter's first video, real numbers. So on the top, whenever you think of maths, you say number system, number system, number system. From first to sixth, our first chapter was mostly number system. When we go deep into number system, we find that number system is broken into two parts. What two parts? First part is real and the second part is imaginary. When we talk about real and imaginary, first you will think, what's imaginary? Imaginary is something new. That's why I'm telling you not to skip this part because it's very important. Yes. So when we talk about imaginary, you will say, what's imaginary? Is it pi or is it something that we imagine? No. Imaginary number is something which has its own sense. It has its own life. For example, you can take an example of a plus iota b. What's iota? Most of the imaginary number contain almost every iota. What's iota? Iota is root of minus 1. And from that you can say that a plus iota b is type of a form of imaginary number. So remember, iota is root of minus 1. And whenever you are stuck in a quadratic equation like 1 plus root of minus 8, don't struggle. Write a 1 plus 8 iota upon 2 and that's final form. Because you know that root of minus is actually nothing. Now, when we talk about real number, what's real number? You can say real is equal to rational irrational. I'm writing IR. Rational and irrational. IR means, okay, let me write like this. Rational and irrational. Now you will talk about what's rational and what's irrational. Then let's go little bit deep because it's something common. When we talk about irrational is something which could not be written in the form of a ratio. In the sense, if you talk about irrational, could not be. Like what? Like root of 2 upon 3 something, root of 2 upon 4 something. These are rational. Why? Because these could not be written in the form of a rational. They are not rational, so they are rational. In sense, talk about like this. Make it clear in your head. But you will talk about what's rational now, what you are talking. So let me tell you, rational is nothing. Any number which could be written in the form of p by q. Sorry. Where p and q, p comma q are co-prime. P comma q co-prime are co-prime and they are written in the p by q form. They are rational. Like 2, 3, 4, 2 upon 4, 5 upon 6, 7 upon 8, blah. They are all rational. Now, hear me carefully. When you go deep into rational, before that, listen. In real numbers, there's a very interesting thing, the density property. When we talk about density property, then always keep in that head that between any two real, there are infinite, then I am writing over here real numbers. Just remember this property of density, that between any two real numbers there are infinite real numbers, and that's very important property, density property, which could come in many exams. Moving on. In prime irrational number, there are three more numbers known as uh, uh, natural, whole, then whole integer. Okay, natural, whole, then the whole integer. Can say the type of natural plus whole belongs to integer. Natural plus whole belongs to integer. You can say that after rational, integer comes first, and from there you can take out these two. Or you can say that prime. You can write it in any form because meaning would always be same. This is how you break the from number system to here. Natural number, whole number. Before that, let me tell you. Now, when you talk about 1 to infinity as real numbers, 0 to infinity whole numbers, minus infinity to positive infinity integer. Can any one of you tell me, as integer, when we think of a map that integer first, if we take a second map that integer first, then divide it in natural and whole, can you tell me which category would prime, composite and odd even numbers? Prime, composite, a second. We first talk about even odd numbers. In which category come? Let me tell you, they will come in whole numbers category. Why? 0 is even. Remember this statement. 0 is even. That's why. Here has odd, it has even. Okay. So this was the starting of the chapter real numbers, and I hope you liked it. So meet me in my next video, which is gonna be very crazy because I'm going to tell you new ways of converting in rational numbers. Meet you in the next video.